Hello everyone. Hello everyone. My name is Jamin Toe. I am a student from Mechatronic Engineering Department. Today I would like to present about how to design fuzzy logic controller by 9 into 9 membership function. So first of all, what is fuzzy logic? In our real life, there is not only 0 and 1 and true or false, yes or no. They are tall, very tall, and short, and low, medium, high, or hot, very cold, cold, normal, warm. That's how many conditions in our real life. Fuzzy logic is a method for designing the computers to make that kind of condition to make that kind of condition and to send the control to our robot. So this is one of the example of using fuzzy logic. This is automatic brake system. So as we can see here, there are two cars, but the car are far or very close or just close but not so close. So many condition we have. So if it's not very close, we will not directly brake, but just slow down. So many condition in this automatic brake system. So we can use fuzzy logic in this system. In our homework, we need to create a 9 into 9 fuzzy logic controller. So at first, we need to have the MATLAB application. In MATLAB, as we can see here in command prompt, we just need to type the fuzzy so we can see the fuzzy logic designer. And if we click the input one, we can see the membership function editor. In membership function editor, input one and output one. Our homework is we need input one and input two and output one. So we need to create one more input. So as we can see here, if we want to create new input, just click edit and add variable. So we can have the new input, input one, input two, and output one. After we create two input, we need to declare about our 9 into 9 membership function. Since we need 9 into 9, also input 1 need to have 9 and output 1 need to have 9 variable. So for my homework, I put input 1 and input 2 with 9 variable, TL too low and L negative large and M negative medium and S negative small is approximately 0. PS positive small, PM positive medium, PL positive large, and TH too high. So the total is 9. And I also created the value for each variable with the range from minus 100 into 100 and distribute for 9 distributed for the 9 variable. And after we create the input 1 and input 2, we also need to add the output. So if it's too low, the range is from which value to which value. In my homework, I do the range from minus 255 into 255, and I distribute that for each 9 value. So after we create this membership variable, we can create the input 1 and input 2 in the MATLAB. So we can create the input one and input two. When we have the input, we have usually only three variable. So we need more membership function, so we can easily create add from the add membership function MFS. So we can create the membership function add new membership function, and after that, as we declared before, where with this rule we created input one from minus 100 and then 100, and the previous variable will be replaced into params. So that's how we created for input one. TL, NL, NM, NS, EZ, PS, PM, PL, TH to the 9 variable, and input 2 as well. I in my homework I do the same membership function. So I added the membership function from minus 100 into 100. So after that, we also need to declare for the output. For the output as well, as I declared before, from minus 255 into 255, and I distributed the data, I added membership function here. So after we create the input, two input and one output, we can create the membership function. So in the real world, most of the researchers use four different graphic pattern with singleton, triangular, trapezoidal, and Gaussian. But in our homework, I will be using with triangular. So we need three variable. That's why I added three variable for when I declare for the membership function. So after that, we need to declare the relationship fuzzy rule for 9 membership function. So this membership function I do reference from automatic generation control of an interconnected hydrothermal system using fuzzy logic and conventional controller. I do reference from this channel, and I created the fuzzy logic, fuzzy function, fuzzy rules in my homework. So to create the fuzzy rule, we just click entitle box, and we can see the rule editor. And as we declared before, if it's too large and too low, the output will be too low. And in my homework, I use the AND operator. So that's how we generated the condition. And since our input 1 and input 2 is 9 into 9, so we get the 81 total, 81 condition totally. So this is the how to create member fuzzy rule for membership, fuzzy rule in for 9 into 9 membership function. And after we create the membership function, we can see that our fuzzy system surface. And to see that in the fuzzy logic designer, just click the view and click the surface. So as we can see here, this is we have input 1, input 2, and output 1. This is the front view, and this is the side view. We can easily drag our mouse to see the side view as well. So for in the fuzzy system, as we can see here, if we add input 1 as 50 minus 50 or input 2 as minus 50, the output will be which value. That's how we can see our system using fuzzy logic. This is the fuzzy system rules. To see the fuzzy system rule, we can click view and the rules. So that's how we can see our rules that we created. So after we created the fuzzy rule, we need to export as a file in our MATLAB in Fuzzy Logic Designer. The file will be saved with .fis extension. After we created the .fis fuzzy function, so we can simulate our fuzzy logic function. Just we need to click the Simulink icon here, and then we can see this Simulink start page. we need the blank model, so we just click the blank model as we see here. After we click the blank model in the play, we need to create this design. We need sine wave, constant, fuzzy logic controller, display, and scope. So after we created the design, and we can run, and the scope of our simulation can be seen like this with the graph. So for to see this one, we just double click to the scope. That's how we can do the 9 into 9 fuzzy logic function with MATLAB. I think that's all for my homework. That's all for my homework. Thank you so much.